my presentation will be in Flutter. It's not a very thrilling presentation, but I found out making presentations in PowerPoint or Google Slides is much less thrilling, and the results are pretty much the same. So here we go. As I said, my name is Krzysztof Krasiński-Sroka, and this is about when Flutter goes red, what to do when the problems happen, right? It's not going to be only about Flutter when it's going red, the red screen of what I call the Whoopsie-daisy. So we actually talk about three kinds of problems. These problems, the problems 0, 1, 0, 2, are actually quite common. So I guess it will be most interesting to any kind of people. Problem third is problem with performance, which fortunately in Flutter doesn't happen all that often. But if that happens, I'll tell you what you can use to actually debug this. So first, I'll actually show what we are going to toy with during our talk. So first thing is a really simple screen that can basically grow. And as you can see, we already find ourselves in a pickle with not that great UI. Something's wrong. We overflowed by 58 pixels. I can't even press next button anymore, even though I should. All right. So I should have applied never scrollable physics or never scrollable physics or never scrollable animation here to this. Yes, so that's the first kind of problems. The problems with layout. What happens if we find that what we expect doesn't really work as expected? And this is quite a common issue, since we use things like columns and rows and list views and grid views all throughout our Flutter apps. This is one of the basic components, and these errors happen very frequently when we don't know how to use these basic components. So the second thing is going to be a simple math game, and I hope it's not going to crash anymore. The math game is a very simple presentation for the young kids who like to learn more about maths. It's not really a game; it's a game of luck. So as you can see, there are several operations. There are several numbers, and some combinations of these numbers might be wrong. And I try on the other screen now to make it go. Let's see. Oh yeah, I need to hot reload. I'll toy a little bit with this. Oh, and this is a problem that we actually want to fix. So we got this infamous red screen. And this red screen also happens quite often, and when it happens, it's mostly because we did something wrong, like the division by 0, which wasn't that smart from my side, right? And now, the next thing we're going to talk about, and some people might recognize this, is this simple game called Game of Life. If you don't recognize it, I added some nice features to actually show the shadow or shade of the past lives. This Game of Life is a very simple game on Solar Automata with some rules that basically is played on a grid. It's not really a game. It's more of a automata that we can advance and see what happens next. And in this particular case, I've added a very simple combination of black blocks here that actually reproduce themselves after several steps. So you can see how it glides through my screen, and will glide forever as long as I press advance. But naturally, this doesn't show any kind of problem. So the problem here is that I can steer the size of the board, the size of the cell, and let's say I'll do something differently, and I need to reload this page. I need to hot restart. Yay. And what happens when I give myself a bit too much space? This is our matrix of 100 rows and 100 columns, is that suddenly things start getting slower. It's not that slow, but maybe I'll just shrink it a little bit more. To 250 by 250. Need to restart it. Whoa, and now you can see I'm trying to even navigate to the page, trying to press a button. So this is unfortunate. Like, of course, we would like to have Flutter as a very performant thing, but sometimes it just isn't. Maybe because we would like to have too much of memory occupied or something else, and we'll see how to maybe debug these problems. But as I said, don't occur very often. They just happen once in a while. And that's about techniques you can use to debug these problems. So I'll list it here several things. I'll call them first, read before you shoot. 2, step-by-step debugging. 3, beyond the basics, the Flutter DevTools. 4, 1 visual cues worth 1,000 logs. And 5, what takes that long? And as you can see, there is a last item over debugPrints, which I thought I might just talk about, but I think it's not going to have time. And it's also more the let me show you documentation rather than anything fun. But if I find some time at the end, I'll actually talk about some debugPrints and what they can do for you. So read before you shoot. Oh no, convert my tiny screen to show you also what I do have in my IDE. So that is my brilliant IDE next to the presentation. Dominic, I do have an Macros app. However, some debugging of performance doesn't really work well. I don't know why. Of course, these applications that I've shown you are here to demonstrate problems. In real life, you wouldn't like to have such a big game of life board probably displayed all the time. Or you wouldn't divide by 0, or you might, after like your second or third try with a column, learn how to deal with these problems with the overflowing widgets. But let us first go and start with the simplest solution to our problems. So you can frequently see both in Stack Overflow, in some chats, or in some Facebook forums that people ask for help. And what do they show you when they ask for help is that I have this code, and they'll paste the code or actually make a photo of the code and then paste it. And I have this application that overflows, right? And I don't know what to do. And then you ask yourself, why do I need to do this? I want to help that person, but that person doesn't give me one thing I want the most, that is text logs. And if you ignore what happens on the console, you are shooting yourself in the foot. And yeah, maybe you have bad experience with another languages like C++, where the errors on the console are really unreadable, and only after some time, some months spent on a very trivial errors, you recognize some patterns of messages being thrown out, and you can basically say, oh, it might be that I didn't terminate a string. Oh, there might be illegal access. In Flutter, one thing that I like the most is the developer experience, and that includes also the debug logs. So if you run Flutter both from console or from your IDE, you can see in various places in various IDEs, but in VS Code that I use, a debug console, which will print out all the logs from the application, or rather all the logs from a device that relate to Flutter. And here you can see we actually got something, and we can read through it. I know it's a lot. We can open something that I'll open up later. But these messages are very carefully crafted to actually pinpoint what the problem is and show you the possible solutions. So if you ever ask for help, please do first check if the logs on the debug consoles or wherever you actually have them contains anything like that, exception codes by rendering library. And in both these and the red screen types of failures, we will see that these errors usually get printed out on the console, and you might be able to actually see what happens there. One nice thing is that works in VS Code, and I think it also would work in IntelliJ-based IDEs, is that you can actually see a link here. So VS Code makes me want to navigate to this link, which in VS Code it doesn't cooperate well. I'll just show you what it does. It goes to the same exact widget that is responsible for this problem. In this case, we can actually pinpoint, oh, this is a column, and this column causes this. It's not a container. It's probably not as low as this elevated button that gets hidden, and it's not as an icon, separate icon code, but it's a column rendering that fails here. The second thing that you can notice is that some text is more grayed out because it's less important, and possibly could be on a bit lower. But the text in brighter white or in brighter gray actually tells you some solutions to what you're experiencing. So it says, consider applying a flex factor, for example, using expanded widget to force the children of our render flex to fit within. Okay, this is complicated. And as I said, Flutter is quite good at it, but sometimes do imagine that this is written by people at Google. So for them, working with Flutter for several years, this is obvious. What does render flex mean? And what's a natural size? Everything is in natural size. And what's a flex factor exactly? But let's just apply this solution using an expanded widget to that column. All right, so let's see if it happens. No. There's another problem. Expanded widget has a wrong ancestor. Expanded widgets are placed directly inside flex widgets. And actually, I read the documentation, so I know, it's within the columns, because column and rows are flex widgets. So I'll just go back and go and say, well, what we can do here, right? We can maybe expand the icon card, the spacer, the elevated button, but it's probably this growing list that makes us go back. So what we could do is wrap this into some kind of an expanded container, like, let's say another, let me write this quickly, expanded child and a column, right? Column with children, and I don't know, like this, right, format, and oh, we have it in different place. Let me just, is that, okay. What happens here? We can still add this. Maybe it's something wrong. Now I have this one. Let's see what's going on. it still is expanded. Oh, and why does it happen in the middle of the screen? I'll show you later how to actually debug this case, but I know how to apply a correct solution here. So what do we actually need? I want this to be, for example, scrollable. We want everything of this to be, for example, scrollable. So how about if I apply some different scrollable widget? Ah, yes, these are scrolls. Why is that expanded here? And I'll leave it at this state, because then we'll go into layout issues to discover, and later part we'll discover why is this here. What did we do? But now instead of showing a full list, we only see half of it. No. So that's the first part, basically applying what Flutter tells you to. Now let's play a math game. Math game is much more fun, because we will go to the calculator class and see, well, this is actually number 1, this is some operator for, and yes, I have some symbols equals. Let me just find where I put the operator. Play a math game button does something here. And here, as you can see, I would normally just grab a random operator, which would make me fail once every 40 times if I'm lucky. But let's say I just always want a division. And eventually, I'll reach a point where 1 in 10 times, of course, when a wrong division is going to happen. For the time being, we can relax, learn some maths. Like, why is it 0? Oh, it's an integer division, so if it rounds everything down. Oh, yes, that's it. So now we got another problem. Obviously, I could show you again, there is some kind of error-causing widget, which was calculator pinch, thank you. And as I told you, this is not going to pinpoint really the problem. The problem is somewhere much, much deeper, right? So, but this problem happened during the build time, and because it did happen during build time, the whole widget actually looks like that. And we cannot really pinpoint what happened, right? There was an exception, something bad. And we could say, okay, this calculator stayed built and so on, but I'm not gonna do this. What I'm going to do is show you a second technique, and it's more advanced, it's much more common in older languages, I would say, which is a technique of debugging. So in VS Code, we can break anytime we want, actually. And we can do this also on exceptions. And in this case, I'll show you what happens when we break and when this bad condition happens. We can also set a breakpoint manually, which will make us actually stop when we try to execute a part of a widget. But that would make us stop every time something happens, right? So every time, for example, we generate a new number, and we don't want to do this. We just want this failure to get caught before we get to see the red screen. Some more. Smart. Maybe next time I'll just do 1, 2, 3. Yes, great. Now, this is much more interesting thing. I'm not sure how well it is going to look like. Because now we found where the exception actually occurs. And this view lets us actually investigate step by step what happened here. So as you can see, we don't have any red screen yet. This is going to happen when we let this exception continue and get thrown. But we caught exactly the moment when the exception happens. Of course, integer division by 0 exception in the operator, that's the operator on integer of integral division. So it's going to cut off basically something, truncate the reminder from the integer if it didn't true. So, and you can see in many IDEs, you would see this very same combination of controls. And these controls are continue. So basically try to continue the execution of a program until possibly next exception, until next breakpoint. Step over, which will try to forward to the next instruction. Step into next instruction on the same level without going deeper into the execution, into the stack. Step into will actually go deeper into the stack of execution, and step out will try to move up, so to the caller of this function, of this operator. And let's go. So well, this is some kind of integers class. On the left-hand side, we can see also variables. Oh, this is going to help. So this integer is 8, and the other is 0. So basically 8 divided by 0 is integer division by 0 exception. And we can add some more variables. I'm not going to show them. I actually, it's hard time. I had a hard time to make them work, but that's why I'm not going to show them. But usually they can be an expressions that you can evaluate every time you stop. But what I have here as well is a call stack. A call stack contains all the known calls throughout all the functions that happened that are on a stack that caused this exception. And if I go upwards, so step out, I can actually see that it got a bit shrunk. So it got to perform rebuild phase. And this is a place where we actually catch the exception. And we can even investigate if we were here to discuss how the internals of Flutter work, we could actually go over here, but I'll just go over what happens here, but I'll just show you how the controls work. So yeah, debug doing build equals false, and build. So this is actually, I'll tell you, this is a widget that we actually tried to build. It's going to be replaced by error widget. And if I step over, I'm moving to another step, another line of execution. I can step into and see, okay, the next thing it tries to execute is error description, building this. And if I can take a look at this is a stateful element. It doesn't really tell me a lot, right? So Flutter is quite a bit magical, but it finds, oh, this is a page that caused the problem, because we have a widget called calculator page. But as you can see, there's no calculator page here in a call stack. That's because when this error occurs, we are not actually inside of the widget. We try to perform rebuild during a set state. So this is a set state call somewhere. And you can see this is self element and inspect every single thing. It's 123 widgets deep. And I had a discussion some time ago about how deep the Flutter tree is. And if you think like, oh, I'm just going to, it's just a few widgets, it's a very simple application. There's a page view, and inside the page view is this, and it's 123 widgets long. So material app page view, this, it's totally crazy. But this is something you need to be wary that, well, we can go really deep, really fast with Flutter. Now, okay, error description, what next? Let's step over, I don't want this. So you can see I didn't really move even in a line because we stepped over some expression in the same line. Now we step over, we don't go inside, we go to debug report exception, and it's going to actually print out everything that we want, but we don't want this. Yeah, it's still something happening. You can see something going on. Let's step out. We don't want to step in. dirty false, doesn't really matter, perform rebuild, and some assertions that true. And if we let it continue, so we could here put some more breakpoints, and I don't know if dirty count is now 1, dirty elements is no, this is not going to happen. Dirty element needs reporting, so this is probably not going to happen. But let's say we try to assert here, and we try to continue. Let's see what it stops. Well, that's very good. And this is another assertion, so probably we don't need this. So let's say, can we reach this point? Well, we won't reach this point anymore. Okay, did I put something over here? Oh, yes, yeah, and you can see also the breakpoints that we set manually over here. Now I will just let every exception continue. So this kind of view is actually quite neat. If something happens and you really want to inspect the data behind it, you can do this in your own. You can do this in your own widgets as well by setting a breakpoint, and then it's really easy to inspect what is the data that causes this problem. Now, when you see in this view the pause, actually it doesn't do anything, right? The application continues. This error is no more. It's just a widget, and we continue. So that's the second technique of debugging our application. This is a very lengthy topic. How to use these controls, the breakpoints, how the conditional breakpoints that you can set when some data is equal to something that you want, and inspecting calls like these watch variables, watch expressions and variables. This is really deep topic, and I invite you to actually dive deep into it if you want to master the art of debugging. Debugging not only Dart code, but actually any code, since as I told you, most of the languages have the very same idea on debugging. Okay, so I'll just close this core patch that was opened and get here. All right. So we have this nice glider that glides through my page, and it's pretty performant. I can show you now a simple thing that we do with performance problem when we try to debug performance problems. And usually we won't do this in debug mode, but I'll explain to you why. And we'll just show the performance overlay. I need to save. Yay. Which we will start. This performance overlay doesn't really show much, but you cannot read what's here, these labels, because it's on the wrong kind of background. But what you can see is actually the performance of Flutter during the both UI phase, that is a phase that is controlled by Flutter, and the raster phase, this is controlled by the Skia engine itself. And whenever you see a high bars like this, that means that something took a long time. We ideally would like everything to happen below the bottommost line that you see here. But if something shoots very high, well, this is a serious problem. Now, I told you we're not going, as you can see, there's a label called debug here. We are not going to do in real life debugging this performance issue on an application in debug mode. You would need to actually run application in either release or profile mode to see how it performs. In a debug mode, Dart has lots of checks, additional checks that it strips away in release mode that are executed, are here just for development purposes. All the assets and all the heavyweight stuff is there. So if it happens to you that you have a performance problem, then first thing that you do is actually run it in profile mode or run it in release mode and see if a problem exists. If a problem doesn't exist in release mode, that means that something heavyweight done in debug mode, maybe some calculations that are hidden by assertions that are stripped out by Flutter. But normally, if it doesn't happen in release mode, it's not a problem. Right? It might be a problem for you as a developer because the app is slow to work with, but then there are easy things to do when you just try to avoid the problem with some widget being slow in debug mode, like removing it. Now, of course, this is a very small board, and I'll just go to the file here, Game of Life, and I'll say, well, 250 is my favorite. This is going to require a reader since we initialize. We initialize the state here with these values. And as you can see, well, this is, trust me, there is our glider in the very corner, and it's going to glide through eventually. As you can see, both the threads and both the threads on the Dart side and the threads on the Skia side, they'll take a lot of time to execute. Now, what we could do is use, this is going to be a little bit out of order, but it's since we are here in the code, what we could do is just check what's actually the speed of execution here of something that happens when we press. So we do advance, right? An advance button, if we find it, on state, it executes board, next board. And the next board calculates for all the rows and all the columns. It calculates the next value of a cell. So we might suspect, well, if a board is too big, maybe it takes that much time. And we here can introduce something called timeline. Timeline is a tool from Dart developer package, which is also included in Flutter SDK. And timeline allows us to measure time of execution of both asynchronous and synchronous functions. So we have, so what we do with timeline is that we actually, if we have a synchronous function, that is a function that doesn't do any asynchronous operation, as we can see here, well, this doesn't do asynchronous operation, doesn't do anything with the futures. Next cell is a function that returns a Boolean, it's also synchronous. We use a start sync methods. And yeah, we need to actually wrap it. And this timeline will now record. I need to actually add more operations. This timeline should actually report to us what was the operation here done. Let's see how long the operation took when we executed. The app is quite slow. Maybe it was, yes, I didn't even save it, so it's not even reloaded. hot reload complete after 16 seconds. Try to advance. Okay. Oh, we see 2 dots happening. I can't even scroll. So this is so heavy, my system is actually stopped working. I don't see oh no. I think something got wrong when we tried to do too much. So I'll get back to it in the end when we have some more time to debug this, but timeline is also useful when we try to start asynchronous functions. So timeline has timeline. Timeline can also be used to measure the asynchronous function calls. I actually should have prepared this better, but yeah. And asynchronous calls, of course, don't take a lot of time themselves. Like these are not the calls that would cause this kind of behavior. The performance of the app really sluggishly redrawing the small glider, and only the small glider is just a few pixels that happen over here. But the timeline can also be useful when we measure, for example, calls to the backend, HTTP calls that we don't know how long they take, and we just want to measure how long the Flutter actually takes from the execution of a call to the end of a call. Yeah. Okay, I'll just make the game of light a little bit smaller and reload the app so that it doesn't clog my computer that much. Okay, and if you see actually, the timeline gets overlapped, and this performance overlay gets overwritten with the cycle of execution, and now the these big spikes happen really rarely. They actually will happen more often if I click a bit faster on the advanced button, but yeah, in regular work, they don't even seem to be noticed. Okay, right. So I'm gonna also show you the 2 things. I'm gonna show you now the most advanced thing that Flutter developer can do. So actually go into the .devtools. So .devtools or Flutter DevTools, because it's been renamed, but I don't know really what's the official name right now, is a set of tools that contains lots of tabs. And actually I'm going to open them in a web browser, because while we can open them in the IDE, in VS Code, it's really very, it needs some work and some love from developers. Okay, yeah, I'm closing the old one. I'm launching the DevTools in the browser again. Yay. And DevTools is a lot of things. First of all, it's a Flutter inspector, and there was a talk about on this from Majid Hajian on Flutter Engage in the community track, and I urge you to watch it a little bit because he talks more about the Flutter DevTools. But Flutter DevTools gives us several nice things that we would struggle to actually do in ordinary life or in ordinary execution of a program. So first of all, let's get back to this example. Well, I'm going to just dismiss the performance overlay as well, because it's hard-coded here. And I am going to actually inspect what's happening here. Like, what's the problem with this UI? Flutter DevTools have this really nice select widget mode, which I can just point some widgets on some widget and see its layout. So I can see, well, this is actually the icon, yes, nicely. It's embedded into something, and we see this these very thin borders around several widgets. So these basically denote where the widgets start and end. And we can actually go and see, well, this is the layout of these nice widgets. So it's 300 dp wide, it's 56 dp high. And if we go up, see this card. So they're nice cards, and they are somewhere lower and lower and lower and lower. So they should be displayed. Let's see in a list view what happens here. Well, the list view, as we can see, is only half the size. So, oh no. So something's taking up this size. And we can either continue with select widget mode, or we can just try to, go through these widgets here. Now, my time is almost up, so I'm gonna go and very quickly explain to you a few very nice features. So here we can, oh no, yeah, this happens sometimes. And I need to go back into this. So what we can see is this spacer that we've added takes lots of space, right? And this spacer is actually something we had in a code to just make sure that this button is on the very bottom. Unfortunately, this doesn't really work nicely. So we could either remove this spacer, or we could do some other things. I'm not going to go into the solution here. One other thing we could use, the main is latest post. Yes. Let me just go through. And but I'm gonna show you a couple of things that we can do with Flutter DevTools, which are visual things. So first of all, we can show debugPrint. DebugPrint actually shows us much more information about the layout of every widget, and it's very useful if we consider something badly aligned, badly adjusted. It's not very easy because the selection of colors by default is a little bit hard to see. It's not very, it doesn't have a huge contrast, but there are several lines going through the screen. The green lines mean that there is some kind of a row happening here in a directional right, and this is a column or some scrollable container in direction and lower direction. Oh, this arrow here actually is the page view. As you can see, when I move the pages, it stays the same, unlike the other thing. And the blue things are the padding. There are some other things that you can see, and this is really easy. This is easy to show all the layouts and constraints and sizing on a screen without needing to dive deeper into what is where. If we see, oh, there's this kind of widget, or there's, for example, widget that has a huge frame around it, we can go and pinpoint the problems much easier. Let's also show paint baselines, which is not going to be very visible because we just have one button and the baseline is barely visible, but it's something that you might want to take a look at when you go deal with text. And one fun thing I would like to show you is the repaint rainbow. So repaint rainbow is very similar to what we've seen before. It's actually going to draw some kind of colorful frames around widgets that change, widgets that need to repaint. And we can see what happens when we try to, it's not going to show very well, because the outer layer overlaps with the lower layer. But when we press the button here, the button's border changes on various colors, but also the bottom line here. And this actually means that the whole container gets repainted, even though nothing changes here. So there's some problem of too many repaints happening. You can see, for example, here, there's something being repainted in several places. So if we have also performance problems with, for example, huge stacks of things being repainted, we can use a repaint rainbow, which is going to show us very nicely now, which parts of the application get rebuilt every time we do something. And if you go into your application, enable this and see like everything's just changing colors magically, this probably means, and without of course any interaction from a user or any movement on the screen, this means that you have a problem and you repaint your UI way too often. In practical terms, what we could see over here, maybe let's just go over here. You could see that every time I press a button, the color here changes, and this actually indicates that the whole container is changing, even though these icons don't change themselves. The icons are getting painted just on demand. So if we see this kind of problem, I'll just show you a simple technique on how to fix it before I finish. There is something that's a very nice tool called repaint boundary. And we can use repaint boundary. So the default algorithm for repainting things is that the Flutter, when it repaints a smaller widget, it tries to go up, up, up until it finds a repaint boundary. And when it finds a repaint boundary, then it tries to distribute repaint from that repaint boundary down until, of course, it meets either the end of the widget tree or another repaint boundary. So if we wrap something within repaint boundary, we create like a separate space of these widgets to repaint. Of course, there are other elevated button and text are complex widgets. This is not just two of them. And if we do this, you can notice that now suddenly when I press this button, of course, additional elements get added as usual. This line no longer changes, so this color no longer changes. So we avoid repainting the whole application here. Okay, I'm out of time. I'll just show. I'll just move this away. And oh yeah, let me disable the rainbow, which is going to be it's not going to show. Oh, let me rotate this thing again.